In academia, KPIs or key performance indicators such as number of papers published or number of times that our paper has been cited by other researchers are often used by the university as well as granting agency in determining the relative success of research projects, as well as a general measure of a researcher's productivity that are often used in the consideration of academic promotion, the awarding of research grants, as well as benchmarking amongst research universities. In this video, we're going to take a look at how we could use the Google Scholar data in combination with Streamlit in order to create a web application that will allow you to query a university and retrieve Google Scholar data of researchers. And so for example, this is my own Google Scholar, and if I click on Mahidol University, which is the university that I'm working at, we're going to see the list of researchers and also along with the number of citations that each researchers have. And if we take a look at another university in Thailand and we click on it, then we also see the citation data along with the name and the affiliations of the researchers, as well as the research field of study. And so in this video, we're going to consider universities in Thailand, and we're going to build a Streamlit web application. And so let's get started. So the web scraping capability of the web application that we're going to build today will take its inspiration from this particular blog post, where Dimitri has gone into great depth in showing us how to implement web scraping of the Google Scholar data in Python. And so we're gonna adapt some of the codes in this particular tutorial blog, and I have already integrated that into the code. And so I'll provide you the link to the blog post in the video description. And so this is the app.py file for the Streamlit app that we're building today. And so here we're going to house it within a folder called Scholar, and then the script file will be called app.py. Okay, and so let me see which folder I am in right now. So I'm in the Streamlit folder, and so I will have to change directory to the Scholar folder, ls to see the files, and then I see that there's the app.py, and then I'll activate my Conda environment. So a point of note is that you could create your own Conda environment and then use that to install all of the prerequisite libraries. So in this particular tutorial, we're going to need Streamlit, of course. We're going to need pandas. We're going to need the beautiful soup, and then the request out XML, and also the OS. And so for BS4, this is the beautiful soup. You also have to pip install that prior to this tutorial. All right, and so let me show you the application in action. So we're gonna type in Streamlit run app.py. Wait a moment. All right, and there you go. This is the application that we're going to build. And let's have a look at the interface here. It's a very simple application. So in the sidebar, it will allow us to select the university. So as default, we have Mahidol University. And if you click on it, you'll be able to select other universities. And if you select another university, then the data frame here will be updated to be researchers belonging to this particular university. And you're going to see here that the data frame contains 10 researchers, okay? And if you would like to increase the number of researchers, you could adjust this number here. If you adjust it to 20, then you're going to see 20 researchers here. Wait for it. All right, there you go. So you're going to see 20 researchers. Let's have a look at the columns. So the first column is the name of the researchers. The second column is the ID of the Google Scholar. Third column here is the affiliation, a part of this university, which department or which faculty are they from. The interest will be the research interest of the researcher, and then the citations column will have the citations. Citations means the number of times that a particular research article has been cited by other researchers, meaning that a research article that has been published, whether it has been referred to by another research article, and this is called citation. Okay, and so as you can see here in this app, we're going to provide two basic functions. Let's increase it to 30. So the more number of researchers that you select, the longer it takes for the calculation. Scroll down, And this is yours truly. All right, and so let's have a look at the code. Let me open this side by side, put this to the right, and then we're gonna put the code to the left. All right, and so let's explain the code. So the first 4 lines will import the necessary libraries for this particular application. So Streamlit is the web framework. Pandas will allow us to manipulate the data frame to create a data table here. BS4 is the beautiful soup, and so beautiful soup is a Python library that will allow us to web scrape the data from Google Scholar. And the libraries here request LXML and also OS are used by the beautiful soup. Okay, so lines 9 through 16 will define the headers and the proxy, which will be used by beautiful soup. So essentially what we're going to do here is we're going to use the request to retrieve the web page of the Google Scholar having this particular URL, okay? And once we have retrieved the web page, we're going to use the beautiful soup to perform web scraping. So the web page is essentially an HTML file, and so beautiful soup will allow us to perform web scraping in that it will look for HTML tags, and then for each of the HTML tags that we see here, we're going to assign it to the various variables, which corresponds to the name of the researchers, the ID, which is right here, the affiliations, which is right here, the interest, the research interest, which corresponds to this tag, and the number of citations, which will correspond to this variable. The citation is the last column here, okay? So in this particular custom function, we call it getProfile1. And so it will essentially retrieve all of the data that are displayed in this data frame from the HTML web page here, which is assigned to the HTML variable. And when we have already retrieved the data from the web page, we're going to append it to entry list, and an entry list here will be used to create a data frame. And then the result of this custom function will be a data frame, which contains the data shown in here. Okay, so this is the first function, getProfile1, and the input argument will be the organization ID. So what is the organization ID? So make note of this particular URL. Let me go back here. Let's go back to Google Scholar. Okay, let me search for myself. And then click on the university. All right, and make note of this URL. It's right here. Organization ID is this ID here. org equal, and then this ID is the ID of the university, okay? And if I change the name of the university, I will get another ID, okay? And this is another ID for the university here. The org ID is this one, 10884, okay? Head over back. It's right here. And so we're using f-string, shown here, f string, where the org ID will be replaced by the input that we're going to put in. Okay, so we're going to make use of this function in just a moment. And here you're going to see that we have get profile too, and then we have next link and page index. Okay, let me show you in practical application. So when we search for the organization ID, let's go back here. So this is the first page of the organization ID of Mahidol University. And you're going to see that there are about 10 researchers on page number 1. Researcher number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is the first page. And if we use beautiful soup to scrape the first page, we're going to get only 10 researchers. And so in order to get more than that, we have to click on the next page. And note that to click on the next page, okay, this is called the next link. And note that the first page, there is no previous link. But for simplicity, in this particular example, we're going to make use of the next link. So the next link and the page index was not described by the article by Dimitri. So I improvised that in this application. And so in that original article, the example shows you how to get the first page. So in order to get more than 10 researchers, we have to go to the next page and subsequent, right? We have to go to page 2, page 3, page 4. But the thing is, when we go to page 2, the ID will be different. Okay, if we click on the next one, the ID for the next link of page 3 will be different from page 2, right? And so that's the tricky part. And therefore, we have this. We have next link and we have the page index. So the page index will allow us to keep tabs on which page are we on, pages starting from page 2 and beyond. Whereas page 1 will be provided from the getProfile1 function. And getProfile2 will allow us to retrieve data from page 2 and beyond. Okay, so page 2, 3, 4, 5, 6, 7, 8, 9, 10, etc. And essentially, the contents of the getProfile2 will be the same as the getProfile1 because we're going to get the same data here. But with the only difference is that we're specifying the next link and the page index. And so the next link and the page index will be used. Let me show you where is it used. Right here, next link and the page index. So make note that it is right here after author, and also the A start. Okay. So on the first page, you don't see it in the URL. Okay, this is page 1. But when you go to page 2 and beyond, you're going to see that there's an additional content in the URL, which is the after author equal, and then there's this ID. So this is the ID that we need. And then the A start equals 10. And if you click on the next page, the number here will change. Okay, this is the next ID, right? It will change. And then the A start is the page index. It will also change. It will be 10, 20, 30, 40, 50, and then the page ID will change. Go to the next page. As you see, page ID changes. Okay, and so how do I retrieve the page ID? I use this developer and developer tool, and I take a look at the tag right here. I'll click here, and then it takes some time, maybe half an hour, to figure out which of the class here belongs to the next page link that we need, and which one corresponds to the number here that we need. Okay, so that takes some time, and so to save time, this is what we have. We have the next link and the page index. Okay, so we have two custom functions, getNextLink1 and also getNextLink2. So the tricky thing is like this. I decided to make getNextLink1 to work on page 2, and then getNextLink2 will be working from page 2 and beyond. Let's have a look here. Retrieve the next link from the Google Scholar page. Yeah, okay. So we have getNextLink1 and 2, which will be responsible for getting the ID right here, okay, that are in the various pages starting from page 2 and beyond, where getNextLink1 will work for page 2 and getNextLink2 will work for page 3 and beyond. Okay, so these constituted the first 90 lines of code. So all of these code blocks will allow us to create the data that we see here, to web scrape the data from the Google Scholar page. All right, and so now let's have a look at the Streamlit component. So here we're going to set the page config to have the layout to be wide, meaning that the table here will expand to the full page width. So if we have a small page, it will fit to the page width here. And if the browser is expanded, the table will also expand to the full page width. Okay. Line number 98, st.markdown, and then we use a hashtag, which is h1 heading, and then we call it the Scholar app. And actually, we could write some description here. This app retrieves researcher citation data from Google Scholar. Okay, so that we want to make this in italic, we will do this. Italic and bold, we'll have 3. If we have 1, it will be italic. If we have 2, it will be bold. If we want both bold and italic, we need 3. Let's save it, and then it'll ask whether we want to rerun the app, and then we'll say yes. But then let me make this to be 10 so that it'll run faster. And so we see here, this is the description. Line number 103, this is the sidebar header, and we call it app settings, which is right here, app settings. We could change the name here. Maybe we call it Scholar app settings, save it. And we could tick on the always rerun. Otherwise, it will ask us every time we save the file. See, now the header here is changed. And the organization list provided here is a dictionary, where the key is the name of the university, which will be displayed here in the dropdown. And then the corresponding value of the dictionary will be the organization ID. So each university will have a unique organization ID. And so you could feel free to change the universities here to other universities of your choice. And I have already shown you how you could do that. So you could rewind to the earlier part of the video. So let's hop over here. So before in the prior implementation, I used the text input, but now I'm using a dropdown. So actually I could just delete this line. All right, and so line number 115 until 124 will allow us to create the dropdown box that you see here. So we make use of the st.sidebar.select box. And then select a university is the text that we want to display here. And then the options that we see, all the university names here are in this particular list, okay? And then once we have select a particular university, it will be assigned to the org ID variable. Org ID variable will be here. And so let's say that if we select Mahidol University, this value will become Mahidol University, the first one. And then org list bracket Mahidol University will tell us that we're going to take the org list here, bracket, and then Mahidol University, which will allow us to retrieve the value. So when we select a particular university here, we're going to get the particular corresponding value of the org ID. Okay, so it would correspond to this. Okay, so this will be appended to right here, org ID, right here, org ID. Okay. And line number 127, it is the slider that we see right here, the query size. So how many researchers do we want to display? So the minimum is 10, maximum here is 50. And you are more than welcome to change this number to other number like 100 or 200 or 500. But please note that the higher the number, the longer it takes to calculate or to retrieve the data. Okay, so the first 10 is the minimum value. The second number is the maximum number. The next number here is the default number. And then the next one is the step size. So here we have a step size of 10, right? When we select it and drag it, it has a step size of 10. It goes from 10, 20, 30, 40, 50. Okay, and this is the default. And then 128 here is just doing a simple division by 10. Because the thing is, we want to display 10 researchers, and 10 researchers are displayed on one page, and therefore we have 10 divided by 10. And that tells us how many web page do we need to web scrape. So if we select 10, 10 divided by 10 means we need to web scrape from one web page. And if we select 20, it means that we have to take 20 divided by 10, and that gives us 2. And that means that we have to web scrape 2 web pages, okay? And so here, p index, we set it to 10 because first web page has 10 researcher data, and so that is p index of 10. And then we're going to create an empty df list. So the df list will be used to contain or house all of the data frame of researchers from web page 1, web page 2, web page 3, and etc. So it will be a data frame list. And then at the end, we're going to concatenate all of that into a single data frame, okay? And so the magic happens here from lines number 133 until 151. So let me tell you what it does here. So you're going to see that it will have a for list here, and the for list will be using a range of query size. So if the query size is 1, it means that we're going to perform one iteration because we have one web page to scrape the data from. If the query size is 2, it means that we're going to perform the iteration for 2 times, which is to web scrape 2 web pages. And if we have query size of 3, we're going to perform 3 iteration. We're going to perform web scraping of 3 web pages. And so the individual if here are used to determine whether we're web scraping from the first web page, the second web page, and the third web page, and the third web page and beyond. And make note here that the only difference is the input here, okay? So make note that for each of the condition, whether it is web page 1, 2, 3, and beyond, because we have the greater than here. For the first web page, we're going to make use of the getProfile1 function. For page 2 and beyond, we're going to make use of the getProfile2. And for web page 2, we're going to make use of nextLink1 and pindex. And for web page 3 and beyond, we're going to make use of the next link 2 right here, as already mentioned, okay? And let's say that we perform iteration here for web pages 1, 2, 3, 4, 5, and then we have already created 5 data frames, and then the 5 data frames will go into this particular variable, df list. And then we're going to concat it. We're going to perform concatenation using the pd.concat function. And essentially, it will just fuse all of the data frames into one single data frame called df. And in order to allow the ID here, the index ID, to be numbered beautifully from 0 to the maximum number, we're going to use the reset index. And then we're going to have drop equals to true, in place equals to true. Otherwise, it will be 0 through 9. And then number 10 will be 0 again until 9. And then it will be 0 through 9 and etc. So in order to make it 0 through 19, we need to use the reset index. Okay, so finally, on line number 156, we use the magic command of Streamlit by typing in the name of the variable, df, and then we're able to display the data frame into the Streamlit application. And so there you have it, the Scholar app, which allows you to retrieve researcher citation data directly from the Google Scholar website. And so there you have it, a tutorial showing you how to retrieve data from the, and there you have it, a tutorial. And so congratulations, you have successfully created a Streamlit application that allows you to retrieve researcher citation data from the Google Scholar website. And if you're finding value in this video, please give it a thumbs up, subscribe if you haven't already, and make sure to hit on the notification bell so that you'll be notified of the next video. And as always, the best way to learn data science is to do, and as always, the best way to learn data science is to do data science. And please enjoy the journey.